What's up, gang? Today we are going to talk about object-oriented programming. And specifically, I'm going to show you what object-oriented programming actually is. And I'm also going to show you what you have already likely seen or are likely to see if you work with software that claims to be object-oriented or that uses stuff that is associated with object-oriented programming, but it's not really OOP. Okay, so it is important to understand the distinctions here so you understand what object-oriented programming, I'm just going to say OOP from now on. So you understand what OOP is, and you will recognize when you're actually using it versus when you're just using some of the conveniences of OOP, all right? So let's dig into this. We're looking at my PageMotor test site right now. PageMotor is a content management system that is a replacement for WordPress. And it is completely object-oriented, okay? The components that make it what it is are they're all objects, and they use objects the right way. Now, to illustrate this, we're actually going to look at some code today, all right? And the first thing we're going to look at is a little thing I built to work with WordPress, and specifically to create e-com integrations with MemberPress, which is a nice plugin for a nice e-commerce plugin, and so it integrates MemberPress with WordPress, but it requires the use of the Thesis theme engine and the Focus WordPress theme, and both of those are they have strong elements of object-oriented programming, and so we're going to take a look at that because this is a nice illustration of how you see OOP in the wild, and I can use this to draw a distinction about what OOP really is and what it is not, okay? So we're looking at my little integration. It's not a plugin, it's actually a box for Thesis. And so Thesis is an object-oriented system, and it has something called boxes, which are like WordPress plugins, but they're more powerful. They inherit a lot of functionality. That's actually OOP. If you're using the PHP language, you can recognize this whenever you see that there's a class and it extends some other class. That's true, that is called inheritance, and that is true object-oriented programming. This is the essence of what OOP really is. Extensions. It's known as inheritance, but in PHP, the parlance is we say it extends something else. So this new class, Focus MemberPress, inherits all of the functionality that Thesis boxes have, and then it can also do its own unique thing. So anyway, we go through the code here. We're going to notice stuff like this, and you've probably seen this if you've ever dealt with any reasonably well-coded WordPress plugin. So MEPR, this is MemberPress, and so this is referencing a class here, MEPR options, and then I'm calling the method from it known as fetch. A method is simply a function that lives inside a class, inside an object. So functions live out by themselves in the overall namespace that exists within software. So like you can't have anything repeated within the namespace of software. So if there is a function in the whole system known as fetch, you can't also have a function called fetch unless you stick it inside an object. And then within each object is an infinite namespace. So you can if there's a function out in the global namespace called fetch, you can't just put another function in the global namespace called fetch. That will create a conflict. But if you create an object and then put a method within it called fetch, then you can have that method and use that name. Hopefully that makes sense. Hopefully you've done enough programming to understand what I just said. Okay, so anyhow, MEPR options, this notation, this two-dot notation is known as a scope resolution operator. All this really says is it says, hey, within this class, give me this method. So this is not true object-oriented programming. Yes, there is an object here, and yes, we're referencing that object. But all we're doing is it's basically an organizational tool. We're saying, hey, give me this method from within here. That's it. That's not using inheritance. Inheritance is the essence of OOP. If you don't have inheritance, you don't really have OOP. But a really good use, a really smart and good practice use for objects within any system is to use them for organization. So in this case, this is all the options for MemberPress, and the method fetch grabs all the options for MemberPress. So that's nice. Using objects in this way is something you're going to see within any decent system, the organizational aspect of objects. And this is a good way to mentally kind of think about where you're at and what you're doing. You say, okay, I'm at this point in my program, I need this thing, I need these options. Well, it's real nice to be able to say, okay, I'm going to access the overall options object and then get what I need. So that's a good organizational tool. It's a good tool to help you think and to help you, it's good for clarity. Like where you are operating within a program, what you're accessing when things are organized this way. So this is good, but again, this is not OOP. And the use of the scope resolution operator treats this class as, it treats it as a static class. What that means is that tells the system, don't worry about any objects that have actually other objects that have actually inherited this and really used OOP. Just give me this thing from this class. So it's really, at this point, it's just an organizational tool. It's a tool for reference. But that is not OOP. That is just a reference. So in my software, you will never see a scope resolution operator, because this is not really OOP. All this is in this case is organization. It's better than just having a bunch of random functions out in the namespace, which is how most of WordPress is put together, but it is not OOP. So let's look at some more stuff. Here's another one down here. We're accessing the MEPR CPT model. I'm not really sure. I don't know. Custom post type is probably what that means. So we're accessing that, and we're, again, using the scope resolution operator to call a method with the name all, and then we're giving it a parameter to this method. We're saying, give me MEPR products, which in this case, this gives me all the products that have been registered to the MemberPress installation on this particular website. Again, this is just a reference. This is not it's not OOP. It's just for organization. But WordPress does use some objects in a similar way. So here's the user object in WordPress. Actually, this is the user object from MemberPress, but it pulls from the WordPress user information. And so I got the user object, I got the current user's information and stored it here. It gives me an object in return, and then I use this notation to say, give me some thing from within the user object. It can be, you can get a property, which is just a variable that's stored within an object, or a method, which is a function that's stored within an object. So in this case, I'm accessing the active product subscriptions for the current user. This notation is something you will see in my software because this is truly an object reference. Here's the object itself, and then the arrow says, give me something within the object. So this is better than this static reference as far as following OOP principles. So this is decent, but again, this is still just a reference, but we're referencing an active object. But really, I've kind of forced the issue here and created this object that is not, it doesn't exist by itself. It's not something I can just go grab. I had to call it. I had to create it by calling this MEPR utils, MemberPress utilities class, and I got the current user information by doing that. So again, that's really still just functional programming. I'm asking for something, and I'm calling a function to ask for it, but I'm using these function names. These aren't going to muddy up the global namespace. They only exist within certain MemberPress objects defined by MemberPress. So that's better organization than just having a bunch of functions floating around in the global namespace. It's better organization. It's a more clear way to operate, but it is not OOP. It is not. Here's again another example of this. I'm accessing products. And so everything within MemberPress, I'm calling static classes I'm calling classes statically and then accessing either a property or a method within those classes. So those are not true objects. They are objects, but they're not inherited objects. They're not examples of true OOP. Now, with that little background in mind, let's go look at some actual objects and actual examples of OOP. We're going to go into PageMotor, which is, again, the software that is replacing WordPress. And PageMotor it has stuff that I would call organizational objects, like the main PageMotor object that when you start up the system, let's see, I'll just walk you through it real quick. It says, hey, start up a new PageMotor object. It's still using the working name PageGrill here in the code, but it is PageMotor, and then call some methods within that object, initialize and then run, okay? So when we go into the PageMotor object, it sets everything up. It sets up directories and stuff, files. It sets up a bunch of objects within this PageMotor object: tools, options, content, page, things of that nature. And now when we go into the actual software, into something within the software that's actually doing stuff, we're going to use object references such as this. So we call in the global, the PageMotor object, and then we can reference stuff. So we're calling PageMotor, we want the options object, and then we want the delete method from the options object. That's what this particular line of code says, and this one says we want to update. So this is a nice chain of reference that's all object-based. So we have the outer object, we have an object within it, and then we have a method here. So everything, so this is a real nice example of organization, because now anywhere in the system, if you want to grab information, you grab the global PageMotor object, and then you can reference living objects within it. There's nothing static at all. These are the actual living objects that have all the information you're going to need already, which is very efficient compared to the other method I showed you before, where you have to just call a method and it's just gonna run right then and there and you get what you need. In this case, you're still doing that. You're calling a method, you're getting what you need when you want it, but these objects that you're calling are already set up with tons and tons of information and everything you're going to need, okay? So these arrows indicate layers of objects: the PageMotor object, the options object within it, and there can be infinite levels of that kind of nesting. You know, if a system's really complex, it might have a bunch of, it can have tons of objects within it. The PageMotor object does have quite a few objects within it, like I showed you: tools, options, content, page, plugins, themes, the active theme, the admin theme. There's a lot going on there. But still, this is just examples of organization with objects. So far, we're still not looking at anything that's truly OOP, okay? Now, let's get into what's actually OOP. There are two components in PageGrill that are actually OOP. They are themes and plugins. Let's look at plugins first, because this is really the most classic example of OOP in the entire system. So to have OOP, you need two ingredients, two main ingredients. The first and most critical ingredient you need is known as a model. You have to have a model. So what we're looking at now is the PageMotor plugin model. It's defined here. A class, and it's still PG plugin is the name of the class. And everything that is going to be common to every plugin that's ever going to run on this system lives within the base model. It includes lots of properties that define what the plugin is and how it's going to work. There's things like options, site options, content-based options, theme options, box options, which are options that exist with it, like the HTML options that are specific to a particular theme, template options, options specific to templates, and then a bunch of other reserved properties that are just used to set up every kind of plugin. So this is all administrative stuff that I would use, but if you were going to build your own plugin for the system, you would never have to deal with this stuff. This is all stuff that helps set up the plugins and helps them do what they do. The first thing we have is a constructor function. This sets it all up. Again, you would never mess with this. But then we have these interesting things that I call valet methods. These are optional methods that you may want to reference if you build your own plugin to equip that plugin with certain functionality that you want it to have. We've got a whole bunch of these valet methods. You can register content types to the PageMotor system. You can register site-wide options. You can register content options. Content options are options that exist in the content editor, like these guys. So we're in the content editor. There's certain options you may want to convey to the content editor. These options are saved relative to each individual piece of content. Things like a custom title tag, meta description, special meta robots designations, that kind of thing. We've got theme options. Those are options that are going to be specific to a particular theme. HTML options, box options, template options. You can have an uploader if you want your plugin to be able to upload an image. You want a user to be able to upload an image or something like this to your plugin, or maybe even a zip file. It could be anything. You can register JavaScript to the whole system. The plugin can. You can register font-specific JavaScript for, like, if you're running Typekit or something like this, you can register that. The system, if you were to do this, if you were to register your own font JavaScript, the system would recognize it and say, hey, I know where this needs to go, and I'm going to output this where it needs to be. So that way, the programmer who creates a plugin doesn't have to go do all that dirty work of saying, okay, where does this need to go? How can I get it there? All that stuff. All those questions are answered by the base plugin model. You can add some CSS to the top of the document. You can add JavaScript. So you register JavaScript to the system. That doesn't mean any of it's going to run. With this JavaScript method, you're telling the system, hey, run this JavaScript, whatever specified here, on whatever page this plugin appears on. You can add SCSS mix-ins, includes for the editor. So that is interesting as well. If we go into our active theme, we can go into the theme editor. Within the CSS tab here, we have variables, CSS variables. Those are defined within each theme. Then you have CSS mix-ins and then includes. And a plugin could register these things. And that, if it were to do that, then it would be registering styles that would get compiled along with the theme style sheet. So that's a really nice way to integrate CSS with any theme just by using the valet methods that exist within the plugin model. And then you also have a preload method. So if the plugin appears on a particular template, and that template is running on the active page of the website, then whatever is defined in the preload method is going to run before the page renders. So maybe some plugin has to do some pre-processing before it appears on a particular page. Then boom, you use the preload method to do that. We've also got valet methods for HTML output. If a plugin appears on a particular page, at the point that plugin is called within the template, so I'll show you what it looks like within the template. We go back over here. So this is the home template. When we get to the content of the home page, when the HTML rendering reaches this point, the HTML method for this particular plugin is going to run. And boom, whatever you define in here is the HTML that's going to output on that page at that point in the HTML document. We've got container open and container close. These are also valet methods. There's two ways you can register a plugin with the overall system. You can say it's if that plugin is going to have HTML output, you can register it two different ways. You can call it a box. A box has HTML output like this, or you can call it a container. And a container doesn't have HTML output like this. It has a container open and a container close, and then stuff is going to appear within it. So this is a container. The stuff that appears within the container are these boxes. So the container open runs, then the HTML methods of any box inside here run, and then the container close method runs once these things have run. That way the HTML output happens in the order it's supposed to. And then there's some other administrative methods. They're underscored. That again, this is just the system uses these. If you were going to create your own plugin for PageMotor, you would not need to reference these things. These are all just kind of automatic functionality that happens. They do things like create admin pages in the right places. So I showed you the content options. that some of these valet methods are responsible for, or some of the administrative methods are responsible for putting this stuff in the right place at the right time. They add plugin options to themes. It puts that stuff in the right place at the right time, outputs it where you need it. You don't have to set any of that up. You don't have to figure out how to convey those options to these pages. You're not risking conflicting with anything else that exists in the system. It all just sets it up for you, and you don't have to do any of this. That's what the power of a true object is, okay? So we have our base model for the plugin, and then we have individual plugins, okay? And the actual plugins themselves. Let's look at one, like the HTML body plugin. So here it is, the HTML body extends the PG plugin, which is the base plugin class. So this is a unique plugin. The base plugin model isn't anything unique. It is a generic model with all the things that plugins need to be able to work within the whole PageMotor system, with lots of valet functionality things and stuff that's done for you. And also, like I said, it's got all these methods that you may want to reference. You may want to reference these to have your plugin have certain types of functionality. So we'll go back. And so we've got some basic properties that we set up. Give it a, the title is HTML body. It's a container. So it's going to behave like a container within the templates, within the template editor, and some other stuff here to help it do what it does. This particular plugin has HTML options. These are set here. This plugin also has content options. It has a custom body class. So this is the code that's necessary to do this. It adds this. What's beautiful about this is that when all I have to do is tell the system, hey, this is what I want for these options, and the plugin model and the overall system already knows what to do to save this stuff to the right place, to retrieve it at the right time. It puts it in the interface so you don't have to do that. All you do is say, hey, I want this option, and the rest of the dirty work is already done for you. That is an example of the power of object-oriented programming. So in the purest form, OOP uses a base model, and then you extend that model, and you tell the model that you're extending, the base model, you tell the base model only what is unique about what you're doing. What is unique about this instance of the base model? What's unique about this one is that it has a content option that is called custom body class. And all I'm doing is feeding it the option itself. This is the actual option that shows up here. And boom, it goes to the right place. It saves, it retrieves at the right time. Everything else, all the dirty work is done by the system. That is, think about how much repetition and how much dirty work this is removing. Like if there's, if people are going to create thousands of plugins, no one is going to have to do the dirty work of figuring out how to get this to display here, figuring out how to style it within the UI, figuring out how to save and retrieve. None of that stuff is going to need to be done. It's already done because through this use of the base model and the extension of the base model, which is inheritance. This is actually OOP. This is what object-oriented programming is. This has got template options. It does a body class. Let's look at that real quick. We go over here to the template. We go in, and this thing is the template has options. This is accesses the template options, and body class, boom, right there, a template body class. Just by telling the system this, it adds the potential to have a body class option on any template. And again, the saving, the retrieving, the fact that this shows up in the right place, right where you need it. It looks like an option. It's already styled within the UI. All that stuff is done. That's the power of OOP. Here's that container open method I referenced earlier. It opens the body tag and adds some other stuff. Here's the container close method. This particular one, since it's the HTML body tag, we like to place, for performance reasons, we place the JavaScript at the end of the body tag, or right before the closing body tag. This plugin references the PageMotor object. It references the current theme. Now, the current theme in this case could be the admin theme or the regular theme, the front-end theme. So it figures out which one we need to reference. It references the appropriate theme, and then it references the JavaScript object within the theme, or the JavaScript property, pardon, and it goes through, runs through the JavaScripts that are supposed to run on the current page, and then it spits them out. Ultimately, it spits them out right here. So it spits them out before the closing body tag. All that is just done. If you were going to register your own JavaScript, you don't have to say, hey, please output this here. It already knows where it's supposed to be output, and it does all that for you. So there's no need to hook in or filter anything, none of that stuff. Your plugin registers some JavaScript. It said, hey, system, I need you to run this on this page. It all just does it because of the way this stuff works. And this is accomplished through all these object references. This is object-oriented programming. So that is an example of a plugin. Let's look at one more. We'll look at the page. We'll look at the page container. Why not? So here's the page container plugin. It extends the base plugin model. It's got a title. This one has a name. A name. If you give in PageMotor, if you give a plugin a name, it makes it multi-instance. And what that means is you can create a new instance of something within the template editor. We might want, like an HTML document, it's going to have a lot of HTML containers within it. Think of those as divs. You want to have a lot of those, so you can create a new HTML container, add it to the current environment, and boom, I could drag this over here and have a new container within my template. And then I could put stuff inside here if I wanted to. That's how you build a template. I'm going to delete this. We don't need it. So that's how you create a multi-instance box or container within templates. And then there's some other information that this thing, some other properties this thing sets up to do what it does. This particular, the page container has HTML options. Again, all it's doing is telling the system I've got HTML options, and then when we go into the templates, the HTML options are conveyed in the right place. They're all saved, retrieved. All that stuff is done for you. You don't have to do anything. And you shouldn't have to do anything. With object-oriented programming, that's the thing. Anything that's a repetitive task has to be covered by the base model. We don't want developers just doing these same basic routine things over and over. We only want developers to specify what is unique about whatever instance they're adding to the system. That is OOP. That is OOP. Only specify the uniqueness. Only specify the differences. If we're all out here doing the same repetitive things in our code, well, we could make this whole process more efficient by having the base models do all this repetitive work that we find ourselves doing. With PageMotor, you're not going to see that. You're only going to see people defining the differences or the uniqueness about the stuff they add to the system. Let's look at the other example of OOP within PageMotor. So really, there's only two. There's only two pure examples of OOP within PageMotor because that's all that's necessary to get the job done. It's themes and plugins. We just looked at plugins. Let's look at themes. So here we have the theme engine, which is the base model for themes within PageMotor. We have two main types of themes in PageMotor. We have an admin side theme and a front-end theme. So this template editor, this runs on the admin theme. This little homepage here for the admin runs on the admin theme. We go to edit the theme options themselves. This is all stuff that runs on the admin theme. Same with the content editor, content type manager. We go in, we select the content type we want to edit. This content editor lives in the admin theme. So the admin theme has some unique stuff that it does, but it's still just a theme. We can control the templates that run in the admin theme. We can look at those. It works the same way. It's still a template editor. It's just referencing some different boxes than you would find on the front end, but it's all works the same way. A theme is a theme. The themes all work the same way. Yes, the admin theme has some unique properties that the front end theme does not, but that's the power of OOP. So we have our basic theme model. And we've got a whole bunch of stuff similar to what we saw with the plugins, a lot of reserved properties that are used by the system. These are underscored. And then some other properties that are going to be referenced by any themes that get created for use with PageMotor. So there's only a few of the ones that there's only a few properties that we'll be setting on each extension of themes, not a whole lot of stuff. So the basic theme model does a ton of the stuff, all the stuff that any theme is going to need to do. The basic theme model handles all the basic theme functionality. Things like design options, display options, things like setting up, activating all the plugins that are running within the current environment. The theme activates all the plugins. We see that right here. So the theme gets plugins. It sets up its plugins property, and it says new. This is the creation of a new object, the PageMotor theme plugins object. It sets up in this PageMotor plugins object, sets up all the plugins within the active environment. It sets up all the stuff to run the template editor. Like there's a whole lot of nuance to the way plugins are activated for use within the editor and all that stuff. But this is all done by these objects that exist within the main theme object. And then we have something similar to what we saw with the plugins. We have these valet methods. We have content types, display, that's for setting up display options. Content types are for setting up content types within PageMotor. That's things like this. These are content types. The home page is a content type, page content type, 404 page is its own content type, and then there's a plugin registered to the system right now called modular content. Modular content has its own content type. So we've got content types, display options. I'm not using these yet. I might get rid of these in the end, but I think I'm going to use these. This is things like you could have a theme, and the theme can operate a few different ways. And you might want to say, hey, I don't want to show, don't show me the site title in any pages. I'm just going to use like an image and some breadcrumbs or something like that at the top of my site. Or like, don't use a byline on any pages, just have a headline, things like that. Or like, it's just stuff like that. You can turn things on and off within the templates through display options. This is an easy way to do that. Design options, these are going to be endemic to any theme. We'll look at some design options right here. We go over here. Here's design options. This is really a core piece of themes, in my opinion. So we have a base design, but we want to be able to change stuff like fonts, colors, the layout width, the way it behaves on mobile devices, the way it looks. We change things like our headlines, stuff like that. We want to, might want to make something bold, might want to make something italic, might want to change spacing of things. We can do all that stuff with design options. And it's nice to be able to do that through UI because you can do rapid prototyping. You don't have to go in and change a bunch of lines of code. Instead, you just change a design option and boom, all the changes will propagate throughout the system and your design will change according to what you have done. Really, really powerful stuff. I mean, this is if you haven't used proper design options, and probably have not unless you've used my focus theme for WordPress, if you've not used proper design options, it is an absolute game changer because you're able to make changes that would require hundreds of touch points within CSS, but you can just do one thing and hundreds of other things within your code will change as a result. So like, for example, we're going to look at the front end here. And let's say we're using a font size of 18 right now, but if we make the font size larger, ideally, all the spacing in the entire layout has to change to retain the exact same proportionality. But that's a lot. There's a lot of spacing defined on a lot of different elements. So if you were going to do this for real, if like you were giving this to a client and you got size 18, they're like, I really like the text to be a little larger. That would absolutely suck in most development environments because you would have to go through the CSS and change the relative spacing of everything. And good luck changing all the relative spacing and making every necessary change to make it all perfect. It's not happening. But with this, we can just change the font size to 20, for example, save it, and then we'll refresh it, and everything has adjusted proportionally. Everything has adjusted proportionally. It's still perfect. It's just perfect at size 20 right now instead of size 18. That is so huge. That is so huge. So that's just an illustration of the power of design options, but really design options are an illustration of the power of OOP. We've got stuff like SCSS mix-ins, includes just for the editor. We would use those when we want to make sure that the styling is reflected here in the editor so that what we see in the editor is exactly what we're going to get on the front end. Boom, boom. Oh, well, this is still at 20, but now it's at 18 again. This is at 18, so it's the same thing. You're seeing the same thing. So that is huge. Let's see, we've got some more valet methods here. Register JavaScript to the whole system, font JavaScript. This is the same stuff we saw with plugins. You can register some CSS. So we've got the theme CSS is going to output, but maybe you need to add some other CSS, either for like a font or just like you have a plugin, you're just sticking some CSS in there, ham-fisted style. You can add CSS to the document. Add JavaScript, tell the system what JavaScript is going to run on a particular page. You can add body classes to the HTML body tag, and you can add body classes to the editor to make sure that your styling all works. There's lots of little valet stuff baked into the theme model. And pretty much everything else is all the stuff that the themes are going to have to do anyway to have all this rich functionality, but they're all built into the model, so no one's ever going to have to do this. Initialization all happens, everything happens at the right time in the right place, all the right stuff. All this is accomplished through tons and tons of object references. This is what code is going to look like if a system is truly OOP. You're going to have a lot of object references, probably a lot of nested object references. Pretty much every line of code is some sort of object reference. I mean, literally every line of code here is some sort of, except for like, this is script output. Almost everything is just a bunch of object references. Almost everything. It sets up the core templates based on the content types that are registered to the system. This is super amazing, super nice. So that way, when you go to the theme editor, you've always got access to the, you've got templates registered to the appropriate content types. So if there's a content type in the system, it's going to have an associated output template with it. It's just amazing how much you can achieve through OOP. And it's just alleviating this burden. It's taking this off of developers' hands. There's no reason developers should ever do any repetitive work or any stuff that the system should actually do itself. By truly instituting OOP and using inheritance, this is how you remove that work from developers. Anything that's going to get repeated needs to exist in the base model. This method here fetches the template for the current page. We've got when the template's about to render, we do all sorts of preloading and stuff to make sure that everything that needs to be called gets called. Again, no one else is ever going to have to do this. The system's just going to do this now and forever, amen. We preload plugins. We load up unique template boxes and then call their preload methods. We preload stuff like any scripts that are registered to the current page or that are supposed to run on the current page, any font JavaScript, any additional CSS. Here's the JavaScript. We do preloading, like pre-connection, preloading, and prefetching, which are really nice performance enhancements. So we can look at this. So here's a prefetch, here's a couple of pre-connects, here's some preloads. These are all things that we want to do for performance on every page, but the theme handles it. The theme model handles all this for you, so you would never have to do this. You just tell the system, hey, we want to do a prefetch, we want to do a pre-connect, we want to do a preload, and it will say, all right, gang, I got you. I'm going to load all this stuff up for you and output it in the top of the document, and it's all going to be ready and exactly where you need it. We've got, template output. That's all done. You're not going to have to, write up an HTML document. None of that stuff. It all gets rendered by the system. You never have to do that. You're only writing if you're writing any HTML at all within your template, within your plugins, you're only outputting just the little bit of HTML you need for your little bit of output for your plugin. You don't have to do the whole template. You're only responsible for the output, like, hey, your plugin just got called. Now spit out the output you need. And then, it just appears right there where you need it in whatever page it's running on. We've got and then the base theme model also handles everything for these displays when you're editing your theme options. All this stuff is handled in the base model for the theme. So any theme you create for PageMotor, if you were to do such a thing, you wouldn't have to do all this stuff. You wouldn't have to create the options pages. You wouldn't have to figure out how to convey them to the admin. None of that stuff. That's all automatically done by the base theme model. And so all that stuff, all the saving, all the Ajax saving and stuff like this, like if you go in and save anything, it's got Ajax saving. All this stuff's just going to work. It's already all baked in. You just tell it what the options are, and boom, it just works. So again, all that stuff is baked into the theme model, and the theme model is pretty big. It's over 1,000 lines of code now, and it does all the things that themes are going to need to do. And it does, the best part is it sets it all up in exactly the right order. So like a big challenge when you're dealing with WordPress, especially, and you're adding a theme or plugin, like you've got to activate certain things within your code. And it's this nightmarish dance of using hooks and filters and trying to run your hooks and stuff at the right time, like when everything is actually accessible. So, you know, if you run something and you need to access other information, well, if that information is not accessible yet, you have to figure out a different timing to run your little thing here that gets whatever information it needs. And it can be this nightmarish, bit of trial and error discovery to figure out, oh, okay, I finally get this running at the right time and I can get my stuff. Never do that with PageMotor. That's never going to happen. In a proper OOP environment, everything is already set up to run exactly when and where it needs to run. So there's none of this little song and dance of figuring out like hooks and filters and timing and all that stuff. That is clown stuff. That's amateur hour. In a properly designed OOP system, you're never going to do that. Also, again, in a proper OOP system, you're going to have a ton of object references. Everything is sort of based on object reference. And whenever you're using this notation with the arrow, you're accessing live objects. We're not doing that scope resolution operator where we're accessing static stuff. We're accessing dynamic live options, or not options, objects. Dynamic live objects. These are things that are living within the system. They have properties, they have information, they are full of everything they need exactly when you need it. Super, super powerful stuff. So here's the base theme model. Let's look at the admin theme, which extends the base theme model. Admin theme extends the base theme model. Now, the admin theme does some special stuff that a front-end theme is not going to have to do. It registers some content types that are specific to the admin side. It tells the system, hey, I'm an admin, run me. You know, if this is an admin page, you need to run me. It does things like set up certain admin pages, like this content, the content type manager, and then where you can go in and select which content you want to edit, and then it sets up the editor. It sets up all these admin pages. It also sets up like your theme and plugin component management pages. We can manage plugins. We can upload a new one. We can save what we have. Same thing with themes. You can go in and upload a new theme. We can do that with our admin themes because we have an admin theme in addition to a front-end theme. So we can upload a new admin theme and change it. We can select a different theme. So the admin theme sets up all these admin pages, all this stuff that you're going to want to do in the admin, and then you can extend the admin theme. And indeed, the admin theme that's currently running is called the Chef admin theme. And we can go look at that. The Chef admin theme is right here. The Chef extends the admin theme. So now to get the actual admin theme that's running on this site, we have two levels of inheritance. The Chef theme is extending the admin theme, and the admin theme extends the base theme engine. So that's two levels of inheritance. So now whenever we get to the admin theme, it gets all of the code that's defined in the admin theme and all of the code that's defined in the core theme engine. So really the Chef admin theme that is running on this site is super, super robust, has many, many lines of code that it is inheriting, but I only had to write just a few of those lines of code to actually create this admin theme. All I've done is define some SCSS mix-ins and SCSS includes and editor includes to handle the design of the theme. I haven't had to add any functionality, nothing. All this does is add some stuff that I can use to make the design of the admin. That's all I had to do. Because all of the dirty work, all that functional programming, all that code that tells the system what it needs to do, when it needs to do it, what needs to go where, all that stuff is already done by the base models. And there's no limit to how much inheritance you can have. You can have many, many levels of inheritance. There is sort of a sanity threshold here of like how many is really necessary to define a system. You don't really need that many to do incredibly dynamic things. If you think about humans, you've probably really only got 2 levels of humans. You've got the base model for humans, you know, we've got our bodies, we got 10 fingers, 10 toes, 2 arms, 2 legs, all this other stuff, 2 eyes, a mouth, nose, things like that, 2 ears. And then each instance of a human is just inheriting all that basic stuff about people with a few differences. We define the differences here. Like I have blue eyes, I now have gray hair, I'm 6 feet tall. Those are the differences that we'd feed in, and boom, we get the output of me. And then like for my wife, she's 5'3". She's got different qualities. She's got green eyes. And boom, there's her instance as well. And then my kids, whatever. You get the idea. So when we're using objects properly, we have a base model, and then we have things that instances that extend the base model. And ideally, within each instance, all we have to tell it is what is different or unique about this particular instance. We are never repeating the functional junk that exists within the base model. And figuring out what needs to be in the base model and figuring out those levels of inheritance, that is the essence of OOP. That is object-oriented programming. It is not simply the creation of a class that doesn't extend anything. That is merely using OOP, some principles of OOP for enhanced organization, but that is not in itself OOP. OOP happens when you start extending a base model, because then you are really conveying leverage, I mean, it is incredible that you can, and let's look at the front-end theme. Front-end theme is similar. So in the front-end theme, it extends the basic theme model. So it gets all this stuff from the theme engine, the basic theme model. It inherits all that stuff and knows exactly what it needs to do. It can do design options. It can do display options. It can, it has a template editor. It has a rich CSS editor. It has a way to do custom CSS. It already knows what to do to load up all the plugins within the current environment. It knows how to run everything at the right time. It has these things called editable elements where you can go in and modify stuff that's defined within templates. It knows all this stuff. I don't have to define that when I create a new theme. So I go into the actual theme, the extension of the theme model, which defines what the current theme actually is, only does a little bit of stuff that's unique to it. It defines some unique body classes. It defines body classes for the editor so that the styles can be, shown here faithfully within the editor. It defines design options, which are very rich in this case. So I showed you these. We go to the design options. All this stuff, this huge page of options, is defined here in the actual theme itself. Here we go, big scroll for the design options. It's a lot of options, but all I'm defining here, I'm not doing any real coding. I'm not doing any figuring out stuff or no recursion, nothing serious with code. I'm not even using functions really. I'm just defining some variables, a really nested array of options and telling it this is what I want on that page. It's a lot of options, but again, this is simple stuff. An AI can do this, no problem. So there it is. And then I've got a CSS variables method. This is another valet method that exists within the theme engine. It says, hey, we're going to compile the style sheets. If you want to change variables in a programmatic way, you can use the CSS vars method to do that. So if your theme includes the CSS vars method, you can create a vars array with all the variable references from the active theme. The variable references are all these guys, and you can define new, you can create new variables. You can get rid of ones that exist, although I wouldn't recommend getting rid of anything. And you can reference all of these. You can reference as many as you want. You can reference one of them and change it, or you can reference all of them and change them. It doesn't matter. You can define what those values are, and that way when somebody saves the design options and makes a change to the core, values of the theme, everything else can change. This is the key to that, the CSS VARs method. So this is the stuff that calculates everything in the style sheet. This is all the stuff that a developer would have to go through and do. If the client says, hey, make the font size 20 instead of 18, you'd have to make a lot of changes. But this code in this theme does all that. This is the heavy lifting, and it just does it. This is actually a great reason why I have to do another video about this, but why we really should just have one theme to rule them all. Because of stuff like this. This conveys so much leverage, it is unreal. The fact that you can change one value and many hundreds of values within the style sheet can change to accommodate that change is such huge leverage. It just, there's nothing else like it in web development. This is such a big deal. And then this theme also adds some SCSS mix-ins, SCSS includes, and includes for the editor, and that is it. Really what's unique about this theme is a little bit of stuff with the body classes and the design options and the way the variables are changed in response to what the new design options are. Like when somebody saves the design options, the variables need to change. How do they do that? This method is how they do that. But that is it. That's all I had to define. I didn't have to define like, hey, how do templates work? How do we activate all the plugins? How do we activate all this stuff at the time it needs to work? How can we save and retrieve design options? How do we do all that stuff? No. That's all done in the base model. And then when you create the actual theme that you're going to use, you inherit all of that great functionality that's all done right and can be super refined over time, by the way. It's already really good. But if we find in the future that things need to be a little different in one of these aspects of this theme or something like that, all I have to do is go in and edit the base model, and I can solve any problem. And then any theme that currently exists in the system will inherit whatever changes have been made to the base model. So this is like the ultimate way to do maintenance, right? You don't want to have like 50 themes and have to go change 50 themes because, oh, we made this change to the base architecture and now you're going to have to do this to do stuff better. No, that's garbage. Like that is not an efficient way to propagate changes throughout a system. The efficient way to do it is to change the base, and then everything that inherits the base just inherits these new enhancements. And, that's the ultimate way to do it. That is OOP. Okay, so I think that's enough for today. I hope this has shown you a little bit about the power of OOP and about the true leverage that you get when you're actually using OOP, when you're actually using inheritance. That is the magic word. That is the magic concept. That is the magic of OOP. I think a lot of you have interfaced with stuff like this, which is just references using objects. References using objects are nice for organization, but they are not OOP, okay? And so I can see if you only interface with stuff like this, you'd be like, OOP, no big deal. It's not really better, kind of have to look in all these different places, don't know where to look, need like a directory to be able to do this stuff. I can see why you wouldn't think that that is super great. But I cannot abide any discussions about not understanding why inheritance is great. This is the power, guys. Inheritance is the essence of OOP. This is what makes OOP superior to everything else. It's not even a contest like that. It's not even like, oh, is this method superior to that one? Inheritance is the secret sauce of the universe. I described the human model. You could extend this to like atoms and elements and things like that. Like there's only so many elements. There's like 130 or something periodic elements within the periodic table, and yet we've got an entire universe that's comprised of these elements. Don't you see? That's inheritance. We've got the base model, like an atom. We add a few electrons, and then the atom changes. And just through this basic system of electrons, protons, and neutrons, and atoms, and the configure, putting, you got your element, and then you put a couple elements together, you get a new compound. You can get infinite outcomes by using these simple base models. You use the leverage that these simple base models convey. So OOP is not, again, it's not a style of programming. It is literally the language of the universe. That is why it's so powerful. So inheritance is when objects speak the language of the universe. Inheritance is the secret sauce of OOP. Inheritance is what it's all about. All right, gang? Now you know a little more than you knew when you started watching this video. I hope you enjoyed it. Subscribe to my channel. PageMotor is coming. This is the best system you've ever seen. It is super fast. It is super efficient. If you program or if you build sites with PageMotor and you need to integrate stuff for clients or do anything like that, you will be so much more powerful and efficient than you have ever been. And it will be so much easier than anything you currently do. And because of the way this stuff works, the way plugins work, where you just define the differences and you're really just feeding it an array of data, AI is going to be able to do this. Don't you see? If we're just feeding unique data to a system, you don't even need a human to program this stuff. If the AI knows the syntax, all you have to tell it is what you need, and it'll be able to do this stuff. The leverage that you are going to receive with PageMotor is something you probably can't even totally comprehend right now. It is going to blow you away. So again, subscribe to my channel. Stay tuned for more PageMotor updates. You know now that inheritance is the truth. PageMotor is going to be the first true OOP software you have ever used, and it's going to blow your mind, and you'll never be able to go back after this. All right, gang? Thanks for watching. See you in the next video.